Okay, hi everyone. Welcome. It's actually funny for me to say welcome. It's my first time at this seminar series. So my name is Filiz Garip. I'm a sociologist. I'm also affiliated with SPIA and CIFRI. And today I'll introduce our speaker. But before that, we have an important announcement to make, and Sabrina will give us very important information.
Thank you. I just wanted to announce that we are piloting a composting or organics recycling program with the Scrap Lab for this semester for all of our graduate seminars. So we do have compost bins outside. So after you're done eating today, please make sure to compost all of your food scraps, your plates, and your napkins, but none of the utensils are compostable. Make sure you know that. And then Gina and I will be outside after the seminar to help you kind of go through the process if you need any help, just to let you know. That's it. Thank you.
Thank you. I'm so glad you're doing this. Okay, so it's my great pleasure to introduce Natasha Iskandar. And Natasha is the James Weldon Johnson Professor of Urban Planning and Public Service at NYU's Wagner School. So her work focuses mainly on immigration and development and increasingly on climate change. And she has contributed some of the most important work on migrant workers and how we treat them differently based on their skill level. So if you think about it, we call high-skilled migrants or highly educated migrants brains, and we refer to other migrants by their other body parts like arms. If you think about the Bracero program that brought Mexican workers to the US, it was called Bracero, which means people who work with their arms. So she talks about how we use this language to justify giving different rights to different groups of people. And her book is also very special because it's based on data from Qatar, based on her field work in Qatar, which is an understudied region. And the insights of the book, though, reach far beyond that setting. And the title of the book, I love, Does Skill Make Us Human? So, not surprisingly, this book won several awards from sociology, from other disciplines. Her earlier work was similarly innovative. Her first book compared Morocco and Mexico and talked about how migrant workers from these regions affected development regimes back in their countries. So in addition to these books, Natasha has been prolific. She's published over 40 articles. She's also a public scholar working with many different partners like the World Bank, unions, NGOs on issues related to urban development and workers' rights. So her work has been supported by grants from foundations, from National Science Foundation, MacArthur Foundation, among many others. She's currently a fellow at the Princeton Institute for Advanced Studies. So Natasha holds a PhD in management from MIT. I thought I knew everything about it. I didn't know this. In addition to a master's in city planning. So I've heard Natasha, I've been fortunate enough to hear Natasha talk on many occasions. I know we're in for a treat. And please join me in welcoming her here.
That is really one of the most generous introductions I've had in a very long time, and I'm so grateful, especially since it's coming from Filiz, who I am so much an admirer of. So I want to talk a little bit. I want to take this talk in a different direction than migration at the start. It's going to end with migration because that's kind of where I always end. But I'm going to ask you to come with me on a journey in a new exploration. So this is a new project. So the talk is called Climate Change and the Future of Work. Climate warming will redefine jobs and livelihoods in fundamental ways. Both immediate, it'll cause, beyond immediate job displacement caused by acute climate disasters, there are longer-term employment consequences caused by climate change that will challenge us to restructure the relationship between the economy and material ecologies. Against this backdrop, the literature exploring the relationship between climate change and the future of work is worryingly thin, both in volume and in depth. And it makes a set of assumptions about what is required for economic production. So in this talk, I'm drawing on a new project that starts with the material dimension of production to challenge the assumptions we have about climate change and the future of work. And this is maybe where the management degree comes in. This project is conceived with Nicola Lowe at UNC Chapel Hill, And it looks at concrete as a way to explore both how the changes in our relationships to materials and material ecologies will shape the future of work, but also how our vision of what work will look like will shape our relationship to material ecologies. Okay. So this is the outline of the talk, but let me tell you at the outset that the debate about climate change and the future of work are rich and generative. At first, they look like they're happening on separate tracks, with the future of work conversations really focused on technology, and the climate change conversations really focused on kind of ecological pressures and their effect on work. But in fact, there's a lot of overlap, and the climate change and future of work literature draws heavily on frameworks developed to think about how technology will affect work and workers. And so what I'd like to do is take you through the main argument, take you through these two debates, and then bring you the example of concrete to illustrate where both of these conversations are limiting our imagination of how to think about the future of work and how we actually need to rethink the basis of work if we want to have a chance at a green future. Okay, the materialist argument. Okay, so both future of work and climate change and future of work and work conversations that focus on the future of work and technology focus on employment and work as the social symptom or effect of any kind of transition. They both focus on technology and its impact on work as the driver of change, and they both focus on the standardization and automation of tasks. I'm going to break this all down in a few minutes, so just hang tight with me. Okay? But what I want to show here in this talk is that a green transition requires a changed engagement with the material basis of our economies. And that this changed material engagement requires a different kind of knowledge. It requires situated and relational knowledge processes that cannot be automated. And a green transition will require the development of situated and relational knowledge processes. Another way to think about this is that our green future absolutely and utterly depends on the situated and relational knowledge of ready-mix concrete drivers. And by the end of this talk, I hope you'll all believe me. Okay, technology and the future of work. The motivating belief and assumption in this debate has been that we now stand on the cusp of a new reality where the technological revolution in artificial intelligence and robotics will prove as transformative for our economic growth and human potential as were electrification, mass production, and electronic telecommunication in their times. It will be incredibly disruptive for current jobs, and it may also create new jobs. So some people will lose jobs, and some people will discover new kinds of jobs that are available to them. Okay, let me take you through this analysis. I'm going to go pretty quickly, so if something is unclear, please let me know. Okay, so this kind of debate about the future of work and what will happen to work really began in earnest in the 2010s. And the main focus on of these debates, these analyses, these many working groups on the future of work was a quantitative estimation of the effects of technological displacement. And so you saw this analysis happen on a number of parameters: how many jobs will be eliminated, what percentage will be eliminated, and that ranged from between 13 to 30% by McKinsey, to others that said it was about 45% of work would be disrupted by new technology. There were occupational distribution questions. Is it are teachers and doctors going to be affected by automation, or are we talking about production line workers? What is the educational level of workers who will be hardest hit? What is the demographic distribution? Some research pointing to the fact that African American and Hispanic workers in the US would be particularly hard hit. Is there a geographic distribution? Will the coasts do better? And then questions about wage level. And then some thought about, is this all technology, or is some of this trade, or is some of this institutions, most notably the evisceration of trade unions? And so what you got were a bunch of graphs like these, a bunch of charts just like this, trying to identify which occupations would be hardest hit, what the educational level of those occupations would be, and how many people were in those occupations. And as you can see here, office support is really hard hit in this graph. But what is also interesting, and what I want to draw your attention to, is that builders and mechanical installers are also projected to be hard hit by technology transformations. All right, in the 2020s, which we are still in, we're seeing a second wave of analysis. And this is really driven by a kind of post-COVID reconsideration of how we understood technology due to the widespread and rapid adoption of information and communication technologies during the pandemic. This reshaped work in rapid and what felt like unprecedented ways. All of a sudden, everyone was remote in ways that we didn't imagine possible, and it led to a rethinking of the relationship between technology, work, and workers. Okay, this revisiting of this debate led to an insight that was really confounding. And the insight was that all of this technology, which we adopted especially rapidly during the pandemic, was not producing the expected productivity gains. So productivity has been messy and flat for the last 20 years. So the question was, why are we not seeing the productivity gains that were projected as a result of technological adoption? Okay, so from a focus on jobs, the analysis moved to looking inside jobs, to looking at the content of work. And there were some analyses that said, well, is it technology? Is it the fact that the technologies that we're using are what Darren Acemoglu calls so-so technologies, right? So when you go to the cashier, the automated cashier at the CVS, it works 50% of the time, right? And you actually have to figure out that you need to put your item on the scale so that it registers, that you paid for the, right, that you're not shoplifting, the whole story. Like, these technologies actually require additional work, so maybe that's the productivity lag. Or maybe it's workers. It's all of these workers who are quiet quitting. And that's why we're not seeing the productivity gains. But a whole new set of literature and analysis has actually looked at the interplay between workers and technology in a more nuanced way, and looking specifically at the way that technology is reconfiguring employer-worker relationships and labor processes, with, in particular, an attention to the power dynamics at the work site, and viewing work as a contested terrain in which technology enters and is interpreted, is adopted. In particular, some really key insights are about the use of technology to surveil and control workers. So this is not just using technology to boost productivity, but also to capture worker data, to electronically monitor worker, and to manage them using algorithms. In response to this, there are forms of worker resistance that try to make these new forms of control visible, what some scholars have called algo activism, algorithm activism, algo activism, to try and game the technology to find some scope for autonomy and dignity at work. And then the strategic use of gaps between technologies and tasks. So when you think of production, the kind of the ideal type is to have a seamless movement from one task to the next to increase efficiency. But actually, technologies don't work very well together oftentimes. And so there's a strategic leaving of the gap so that you can translate what one technology does for the other technology. Translate from one algorithm to the next, if you will. And then the ways that companies use workers as the buffer against the ways that technology fails to respond to variable problems, contexts, individual challenges that emerge just in the process of production and work. Okay. At base, this struggle is over how much work can be standardized and specified. How you can divide work into discrete tasks that can be automated and that you can use, that allow you, automated to such an extent that you can use technology to replace human labor. And that this is actually what this tension is about. Work that cannot be specified and standardized relies on a different kind of knowledge. It relies on what I'm calling here situated and relational knowledge processes. So I'm going to define this for you. Just before I define that, let me just draw your attention to, McKinsey had this big blockbuster report out on the future of work, and this was the report that really dominated conversations about the future of work. And the estimate was that 50% of all activities at work could be automated, and that 6 out of 10 occupations had at least 30% of activities that could be automated. In other words, these were activities that were specifiable and standardizable. All of the activities that can't rely on the situated and relational knowledge. So let me define what I mean by that. Situated knowledge is knowledge that is embedded in and affected by the concrete cultural, linguistic, and spatial context of the knowing person, persons, organization, or industry. Right? So it's situated in specific settings, moments, cultural places, economies. Relational knowledge is knowledge developed about interactions between persons, disciplines, functions, and contexts, including ecological contexts, which I'll come back to later. This knowledge is tacit, it is difficult to articulate and standardize, and the skillful action that draws on this knowledge responds to problems as they emerge in specific contexts in relation to specific people. Okay. But this knowledge is treated as a residual, right? So the idea here is to standardize and specify these tasks. In order to get rid of this knowledge, you want to standardize as much as you can so that you can replace more and more of this fuzzy, messy, tacit knowledge by tasks that can be automated, that can be digitized. Okay. As you digitize, you actually require more of the situated and relational knowledge to make the technology work. Okay, a point here about the climate impact of these new technologies. This looks like a parenthesis. It's actually critically important. There's a subtext here that gets lost, where in debates about how robots and algorithms are going to change the world. And the subtext here is that these technologies are incredibly energy intensive. The global footprint is between 2% and 4%, depending on who you ask. It's notoriously difficult to measure. There's been some work done out of UMass Amherst trying to just measure the energy intensity and the carbon footprint of running one basic algorithm training program. And as you can see on the graph here, just running one basic training program, not a super fancy one that's really kind of standard, it's called the transformer, uses the energy equivalent of like 6 cars running 1 year, right? Or like if you look at the human life, the comparison here, you can see that the energy intensity here is really really significant. Okay, climate change and the future of work. So recently, this is a new analysis that's really started just in the last few years. There's an emergent conversation about climate change and the future of work, and this analysis uses a just transitions framework, which focuses on the transition out of high carbon activities and into the green economy, and on the strategies to ensure that harm to workers, communities, and regions is avoided while maximizing the benefits of climate action. And here, the Just Transitions framework is used to think about jobs, which jobs are created and which jobs are lost. And as you can see here, the literature is focusing on many of the same metrics: number of jobs, occupations, educational level, geographic distribution, wage level, et cetera. But the difference here is that the disruptor is not a specific technology, but rather it is regulation. So the estimates about jobs created and jobs lost are attached to specific regulatory interventions. The Infrastructure Act is projected to generate 4 million jobs per year over the next 10 years. The IRA, 9 million jobs over 10 years. And the Clean Air Act, which is one strategy that economists have been using to look at these questions retrospectively, has indicated that the job creation, job loss is kind of a wash. Okay, so the task here that is different than the technology and work conversation is that it's really difficult to define what is a green job. So part of this debate is to say, what do we mean when we talk about a green job? And even more than that, what do we mean when we talk about a green task? And even more than that, what do we mean when we talk about a green skill? And so there's a lot of kind of occupational sorting, sorting of jobs into categories of green, greening, and brown. There's some task analysis, what constitutes a green task in a specific job, and then which tasks in these green tasks can be automated. There's some messiness of understanding of skill, right? Is skill the same as task? Do we know? But very little attention still, and it may change, to what happens inside work. The kind of move that the technology and future of work conversations executed to kind of pry open what happens at work and to understand the power dynamics, the labor processes, that has not happened yet. So what you're getting are graphs that look very similar to the future of work graphs, trying to project which jobs will be in most demand over the next 20, 30 years. But what is interesting is that in this analysis, the debate about climate change and work and the future of work and technology debates make similar assumptions about tasks and the knowledge required for them. They make similar assumptions about the specification, standardization, and the possible automation of those tasks. And in the green conversation, the idea is, how can you increase the number of green tasks in a specific job description, automate them so that you can increase their percentage even more and grow the green economy at work? And the situated and relational knowledge here again is viewed as a residual. Okay, so let's just take a beat to think about what do these debates mean by a green task? The ONET Green Economy Program in the Department of Labor is a program by which the the task makeup of different occupations, so what people do at work, is analyzed, categorized, stratified, and the Department of Labor has opened this Green Economy Program to try and tease out which tasks at work are green and which tasks are not green. This is a little wonky, but it's actually really crucial, and I'm going to tell you why in a second. But the green task, what makes a green task and what makes a not green task, if you read the descriptions, which, you know, the nerd that I am, I have, it's defined by output. It's actually not defined by what is done at work. The result, the output, is always material. A solar panel installed, a hydrogen plant run. The result is always some kind of material output. But the way that the task is defined is in relationship to the technology used. So what you get, if you read through this analysis, is that you start to see that the definition is that green tech makes green tasks. This sounds very abstract until you look at a specific definition. So here are two occupational descriptions. This one is for solar thermal installers and technicians. The other one is for roofers. One is green, one is not. If you look at the content of what they do, it's basically the same. There's no meaningful difference in terms of the skills required, in terms of what is done. So what you start to see here is a conflation of technological change and the green transition for the future of work. So that in both debates, the future of work is defined by technology, technological change, and how many tasks can be replaced by new technology. But what I want to suggest here is that if we took the end result of the O-Net description seriously and started with the insight that what matters for green work is the material output, and really started from there, and started to ask, is the future of work defined by how we engage with the material, we might have a different set of answers about the future of work and a different set of questions about how we get there. Okay, so now let me move to concrete to kind of ground this and make this much more concrete. So let me start by claiming, and I will illustrate this claim in a second, that the engagement with material requires the development of situated and relational knowledge of the material's properties, how it behaves in different contexts, and its different affordances, what it can accomplish, what it can do, okay? And that this knowledge that has been identified as the residual is actually crucially important for dealing with materials, and that not only do we need to value it, but if we want to innovate in this space and actually shepherd a green transition that is meaningful, that changes our material relationship, the economy's relationship to our material context, we need to actually grow this knowledge. Okay, concrete. Concrete is ubiquitous. You may know this, it's second to water in terms of what we use most in the world. And its use is projected to increase about 40% over the next 30, 40 years. It is central to green jobs. It is essential to the transformation of our economies and the development of climate protective infrastructures. And it is also enormously damaging to the climate. Okay, so the manufacture and distribution of concrete globally represents about 10% of annual carbon emissions. So here is this material that is central to everything in our lives that we need to actually make a green transition, and that is intensively polluting. Okay, so what is concrete? At its most basic, concrete is cement, which is a kind of glue, aggregate, which is gravel, stone, sand, and water. You mix those together and you get a concrete slurry, which is that gray, putty, mushy stuff. But that is not actually what concrete is. Concrete is the product of the way that we engage with it. So what you get in terms of concrete depends on how the ingredients are sourced and made. So everything from the chemical process of making cement and quarrying and sorting the aggregate to the kind of water you use, how the ingredients are mixed, so how you design the concrete mix, the aggregate you use. Are you using sand? Are you using gravel? Does the gravel have hard edges? What is the gravel made of? The hydration level of the mix, and the actual process of mixing it. How concrete is poured and cured. So is it poured on site? Is it poured into prefab forms? How do you manipulate it on site? Are you compressing it when you pour it? And what elements are you pouring it around? If you're pouring it around steel rebar, you're going to have a very different output than if you're pouring it with glass fiber, for example. And then how the mix is used. So what building elements is it making? What reinforcements does it go around? What kind of load bearing is it doing? Is it doing compressive load bearing or tensile load bearing? Or is it decorative? Okay, and then finally, and very importantly, how the mix interacts with the environment. So concrete responds to environmental conditions, both as it is becoming itself, as it is hardening. So cold, heat, humidity, wind, but it also responds over time. So a concrete mix that is poured a certain way, set a certain way, will respond very differently to certain kind of climatic pressures than other kinds of pours. Only when you've work through all of these layers can you actually say what you have as a product. In other words, this thing that we think of as a single material is a million different things. And what it becomes depends on how we engage with it. Okay. At each of those layers, how we engage with it is absolutely dependent on situated and relational knowledge processes. So let me just tell you one little function, which is concrete curing, which is the process of concrete going from slurry to rock. So curing is a chemical reaction by which concrete gets hard. It takes about 28 days. It's the reaction between cement and water. And how concrete hardens depends utterly on the interaction between the hydration in the mix and the environment. So for example, in a very hot and dry environment, the challenge of the concrete workers is to make sure that the concrete pour does not dry too quickly. Okay? And so here you see, this is not super high tech, but it's really knowledge intensive. These are just wet burlap sheets on top of concrete. And you need to adjust these day by day, hour by hour, depending on the climate. If you have a cool day and then a hot day the next day, you actually have to adjust these very carefully. And this has all sorts, if you get this wrong, you've ruined the pour. And, whether it's wrong or not may not be visible. If you get this wrong, you get microscopic cracks that completely undo any compressive or tensile strength that you were hoping that your pour would have. So you have to get this absolutely right. And that's everyday micro adjustments that are done primarily by feel. There are lots of attempts to create kind of technological interventions that will measure the curing process, but these don't work. We can talk about why they don't work, but basically they don't work. You actually need people who have the feel for the concrete in the particular climate to understand. The other thing, here's the other tricky thing, is that concrete doesn't harden in a straight line. It gets hard quickly, but not fully hard. So over a 24 to 72 hour period, it gets hard enough so that you can build around it. And it takes the full 28 days to become fully hard. But you have to be able to judge when it's safe to start building around it. And that is also done by feel, by eye, by experience. If you build around it too quickly, you will ruin the concrete pour and you will make your buildings vulnerable to the kind of collapse we have seen in Turkey and Syria. Okay. Carbon dioxide emissions. So let me walk you through this a little bit. Most of the carbon dioxide emissions of concrete happen at cement. Okay, they happen through two main factors. To produce cement, you need to heat limestone up to 1400 degrees Celsius, and that produces about 40% of the emissions. But 50% of the emissions of of all of concrete emissions are produced through the chemical process by which limestone becomes concrete. And this process produces something called clinker, which is glassified lime. Okay. The rest of the process represents about 10% of concrete emissions. And in fact, concrete also absorbs some emissions. Okay. We already have amazing legacy technologies in many cases to decarbonize concrete, to reduce the footprint substantially. In some cases, in some emergent cases, we have the technology to make concrete net negative so that a building can function as a forest, can be a functional forest in terms of carbon footprint. And these are at every point of this process, so adding different supplementary cementitious materials. This is like industrial byproduct like slag and fly ash from coal plants, to carbon capture for the kiln. The aggregate, you can actually carbonize aggregate into gravel. Carbonize carbon dioxide into gravel. And I have some in my office. And that allows you to use carbon dioxide as the material with which you're mixing your concrete, and it becomes a carbon sink. You can use new additives, but most of the gains in terms of reducing the carbon footprint are in the building process. So how you design the mix, how you apply and pour the concrete, designing the structures so you use different concrete strengths for different elements, the management of the life cycle of the building, recycling of the building, and building the building and building its and designing its demolition so that concrete can absorb the most carbon dioxide from the atmosphere possible. Okay. In order to make these innovations work, you actually need a deep base of situated and relational knowledge processes. You need significant cross-disciplinary learning. The innovation occurs at different elements of the concrete mix and at different phases of concrete use and production. But their effectiveness depends on the situated and relational knowledge at other phases. So the effectiveness of the CO2 reductions at cement depend absolutely on the concrete, on the practices in building. Okay. I'm going to give you a concrete example because these are all like kind of very technical and abstract concepts. One innovation that is kind of 20 years old at this point is the addition of liquefied carbon dioxide into the concrete slurry. It's just a little bit, and the company that makes this, or the leader in this space, says that it doesn't affect the concrete mix at all. In fact, it affects it in ways that are pretty substantial, but that you can adapt to if you have the correct and deep enough situated and relational knowledge. Okay, so let me talk you through this. The cement, the carbon dioxide additive accelerates the chemical reaction between cement and water, which means that the mix engineering needs to be super, super precise. Okay? The mix ends up being drier and less malleable. So instead of like a slurry, it ends up looking like, dry dough. And so how you pour it and lay it matter a lot. You have to use really different hydration strategies, and you can't overhydrate. You have to apply it by compression, not just by pouring. And it achieves much faster early strength, but much slower, longer strength. So that has all sorts of implications for how you sequence building. And the people who are crucial in this process are ready-mix drivers, because they will educate the masons on site about what to look for in the concrete. They will translate the environmental conditions to hydration strategies for them. And they will also verify that the mix looks as it should, right? That the precision of the mix made at the plant actually translates to the concrete slurry delivered. Okay. So I've said something about the importance of the relational knowledge, but the current knowledge structure of the concrete industry increasingly is really pushing towards specialization and standardization of tasks. This has been the case even though these tasks are not being automated. This is a kind of a degradation of job quality. And I want to make the argument here that you can actually see this in the material, in concrete itself. So the way you can see it is in the intensity of clinker use. So I told you that clinker is the glue. It's responsible for most of the emissions. And it's the least sensitive component to environmental conditions. So if you aren't sure about the weather, you can put in more glue. If you're not sure about whether or not you can get the mix right, you just put in more glue. If you're not sure that your workers are skilled, you just put in more glue. If you're not sure how it's going to perform in different design elements, you put in more glue. It's just like super glue. You just add super glue, super glue, super glue, and it's more durable. And it allows for the specification and standardization across contexts. You do the same thing if it's cold, if it's hot, if it's rainy, if you're building a tower versus building a floor. So what does this look like? So again, reminder that the clinker is the main culprit in terms of emissions. This is the US. So this graph shows you how much clinker we're using in our cement mixes around the world. And the gray bar is clinker. This highlighted bar is the US. What I want to point out to you here is that the US is the worst performer in the world in terms of clinker use, which tells you something about the organization of industry. The fact that every other country is not using this kind of intensity of clinker says something about the way that the construction industry in the US is organized. Okay. So this material approach to work has all sorts of research and policy implications for us. If we were to take seriously that the future of work in a changing climate depends on our engagement with the material and not with technology, we would have to ask a different set of questions. What would it mean to reframe climate change and the future of work using a material approach? What would it mean to consider the future of work in relation to situated and relational knowledge processes instead of how much can we standardize away and automate away? What would it mean to think about a just transition using the material? Okay, I'm going to tell you the implications in 3 different buckets: industry, work, and workers. For industry, you'd need to have material-based innovation systems. The US is terrible at this. I'll just give you the punchline. The US is terrible at this. One example that illustrates how terrible we are at it and what we could do differently is the different venture capital engagements with cement. So now cement is kind of this hot thing. Everybody's worrying about cement. Maybe you weren't worrying about cement, but a lot of people are worrying about cement. And there's a lot of venture capital money flowing into cement. Okay? But in the US, the support is just money. Okay? In other contexts, like Mexico, which is the national site of a major cement company called Cemex, the support is money plus access to plants to try out your technology, access to sites to try out your technology, with the understanding that being that in order to innovate around the material, you have to see how the material behaves. Okay? The regulatory structure in the US is also not super helpful here. We don't have regulatory incentives built around learning. In the environment space, the Department of Energy has like this tiny, tiny, tiny little loan program that tries to do some of this, but it's not the main focus of the program. Right? They do operate like a standard venture capital outfit, but they're trying. The other thing is that we have regulatory structures in the US that impede innovation in this space, that impede adoption in this space. So for example, in the US, many local regulations will actually specify clinker content. They'll say you need to use 90% clinker, instead of saying you need to achieve this kind of strength. Okay, work. So the implications for work are that we need to make existing situated and relational processes, knowledge processes visible, and we need to value them. The US has this incredible shortage of ready-mix drivers, and the reason is that they're just paid for driving. They're not paid for everything else that they do. So if you're just being paid for driving, you might as well take a job that pays maybe even a little bit more, where most of what you're doing is driving, and all of this other work, you don't have all of this uncompensated work. The other element in terms of work is that you need to promote and develop training institutions that develop situated and relational knowledge. In the US construction industry, we used to do that through unions. And we decimated our unions starting in the 1970s. And you also need to develop cross-disciplinary conversations about what kind of situated knowledge is required. So design and engineers that are using these new concrete mixes actually build ambiguity into their design so that they can have a conversation about what properties does the concrete need to have for this particular wall. Is it load-bearing? Is it a foundation? Is it decorative? How do we adjust? Okay. I'm getting to the migration piece in just 1 second. But I just want to point out, this was a piece that got a lot of attention in the New York Times recently about the productivity of the construction industry. This is a graph from the paper that was cited. So as you can see, the top 2 lines are the productivity of the economy as a whole, and the bottom two lines are the productivity of the US construction industry. It looks like a really sad tale, and there are lots of kind of explanations for why. To me, this is not a mystery. This is the point where unions were attacked in the US and dismantled, and these were the training institutions that really focused on developing this situated and relational knowledge, and ever since then, the construction industry has focused on these very specified, narrow tasks, and that has affected productivity. In terms of concrete, this is also the time where the US disinvested in its cement production, and so is not an innovator at all in this space. And taken together, this is disinvestment in situated and relational knowledge processes. As an aside, you can see that the wages also dropped here as a result of the destruction of unions. Okay, workers. For workers, you need, for situated and relational knowledge processes, you need workers. You can't automate this stuff out. You actually need people to engage with the environment, with the material, and problem solve on a moment-to-moment basis. For this, you need to do two things. You need to improve job quality to attract and retain workers, and you have to recognize and compensate their skill. But even if you were to do that, because of the demographic profile of the US, we simply do not have enough workers to work in construction to carry out the green transition that we now have the money for. So the 4 million jobs a year or the 9 million jobs over 10 years, that represents a significant labor shortage. And so what I want to argue here is that in order to increase the supply of workers in this industry to promote the green transition, you actually have to transform immigration policy. And that immigration policy in the US is actually climate change policy. So let me show you why. Okay. This is a chart from the Association of Builders and Contractors. It's a conservative chart. Other numbers I've seen are much larger. And this is a chart prepared before the IRA was passed. Okay, so all of those 9 million jobs are not included in this tabulation. What this association estimated is that there will be year by year 650,000 new workers required. That is over and above the 500,000 new workers they have to hire every year. Okay, the other problem is that construction workers are older. A quarter are 55 and above, and the retirement age is 61. The older workers, who were trained when unions were still alive, are the repository of this situated and relational skill. Okay. The US construction industry already depends very heavily on immigrant workers. It's a quarter nationally, much more in certain markets, and you can see over time that has become a structural feature of the construction industry. But our immigration policy over the past several years has led to a deficit of immigrant workers in the economy. So we have if we were just following the historical norms, we would have 2 million more workers. So all of the drama about, oh my God, the border, blah, blah, what it's hiding is that we actually have a deficit. And that deficit is not taking into account all of the jobs that will need to be filled due to the environmental policies that we've passed. So in other words, you need workers for this green transition, but, okay, you need workers with full rights. Staffing this green transition with undocumented workers has all sorts of implications for the construction industry. It affects job quality, but more importantly, and here this is based on some of my own research, which I'm not going to go into now, the legal status of workers affects the recognition and the application of their situated and relational knowledge processes. So that even when workers come having this, if they do not have legal status, their skill is not incorporated into the industry. So you need an immigration reform with, to allow for increased immigration with full rights. Okay, so the recap. In industry, you need to create cross-disciplinary institutions and practices to foster the development of situated and relational knowledge about material and processes. For work, you need to create and strengthen training institutions and the valuation of worker expertise. And workers, you need to expand the base of work and workers to retain skilled workers, okay? And then this is where I'm going to end. And I'm going to tell you the story about CEMEX and ready-mix drivers. So CEMEX is a main innovator in this space. They already have a lot of green cement mixes. And they're trying to get the US market to adopt these mixes. They have some penetration in the US market. The mixes are ready. There's some appetite in California and other places to use these mixes. But what they cannot find are ready-mix drivers. And without the ready-mix drivers, there is no one to be the bridge between the cement company and the end user of the concrete to educate the builders about the properties of green cement, or green concrete rather, and how to use those mixes, hydrate them effectively, measure their first strength and their last strength. Without these ready-mix drivers, you will never have a transition to low-carbon cement. And this is where I'm going to end this presentation. Thanks for your patience. I know that this is a little bit of it's very concrete, but at the same time it's very abstract, so I appreciate your patience. Yeah.
I know you talked about how there's been a lot of venture capital money pouring into the cement space.
Yeah.
I'd be curious if you think there are any interesting startups that are helping solve this issue of work specifically as it relates to climate change, and whether you think there are any specific venture capital funds that are doing a good job of supporting those companies.
The short answer is no. Okay. There are lots of companies now in the U.S. like these. The U.S. is sad when it comes to innovation in this space. I just have to say it. There's like lots of little startup companies that are trying new technologies. If you compare this to how other big cement companies are innovating, it's just like little innovations on the margins. But even with those innovations, what you are seeing is that there's a huge demand for the innovations that exist by some companies. So like, for example, in Silicon Valley, a lot of companies with some kind of reputational reasons for using low-carbon cement, so tech companies want to use low-carbon cement for their new campuses, their new buildings, whatever. But the companies that produce this stuff in the US don't have the capacity. So it's not about cost, it's just they can't get enough of it from these companies. One of the reasons these companies can't produce, I mean, the people who are producing, for example, the CO2 aggregate or other things, is that they don't have the workers to run their small little plants. So like, there's a worker issue, but there's a worker skill development issue. Like, there is a labor crunch here. Yeah.
This was really fascinating. It resonated a lot. My brother-in-law works in the union, as a union heavy machinery operator, quarrying for aggregate. And
Yeah.
what always strikes me is how much he talks about the materiality of his work.
Yeah.
I'm wondering about the worker, the kind of the second two issues that you bring up at the end, the organization and recognition of work and the role of workers. Because it seems like the key issue really is that the mediating institution of the union has been lost.
Yeah.
And that would kind of produce this recognition process.
Yeah.
I can imagine some people would say, well, if you increase the supply of workers, that's going to reduce worker power, which is the key kind of structural precondition for building worker power. How do you think about that in terms of your recommendations around immigration?
Sure. So the quick answer to that is no. Okay. Unions were not decimated because there were too many construction workers. They were decimated because associations like ABC actually lobbied very heavily politically, restructured work so that they wouldn't need the apprenticeship model, right? So like instead of, for example, having someone who was a mason, they would break down the task of hanging drywall into like the guy who does the cutting of the drywall, the guy who does the taping of the drywall, the guy who does the hanging of the drywall, like totally like minute tasks, which has all sorts of implications for productivity, right? Like if you hang the drywall on somewhere that it shouldn't be hanged and you don't know that it shouldn't be hanged there, it's a problem, right? So what these companies have done is to fissure the labor market in tasks and in employers, like these massive subcontracting chains, in order to destroy union power. It's really not about numbers. And in fact, one important way for unions to revitalize themselves would be to connect with immigrant workers. In some markets where immigrant workers are really important in the construction industry, Texas, California, unions that are rebounding are doing just that. Some unions are terrible at this, right? Like, and in some markets, they're terrible at that because construction unions, building trades unions, in some markets, not all, are really old school and a little bit racist, like, let's be frank. And so you don't see that. But in the markets where they are, they're actually redefining their occupations and they're expanding their base in ways that make them powerful and valuable to builders. Yeah. Yeah.
So I look at Chinese and Indian engagement in Africa. So one of the sectors we've been studying closely was infrastructure.
Yeah.
So when we were traveling around Kenya and Tanzania speaking to engineers and subcontractors, one of the things that came up was how much Chinese-built infrastructure is going to change the fate of many of these African cities, right? And when we spoke to the African officials, one thing that came up was, tech transfer. You guys are going to transfer technology. So in a sector like this where you talk about situational and relational knowledge, how real is it to be able for these foreigners who are experts in their countries to transfer tech to engineers in the host country who may not even speak the same language?
Yeah. It's a really good question. I have two answers to that. The first is that Chinese companies are operating in Africa often will bring their workforces, right? It's a turnkey operation. They're not subcontracting out major parts of the work. In many cases, they'll just bring the whole enterprise over, do the building, and then leave. So that is one piece of it. The other piece is that I actually don't think that the transfer of this relational and situated knowledge is as complex as it's often made out to be. It actually, it just requires engagement. And the reason I say this is that prior to this obsession with concrete, I did a project in Qatar, and on the work sites that I was on, these are large, very complex, very sophisticated work sites. You had, on a work site of 10,000 men, 22 languages spoken. And the development of situated and relational knowledge was accelerated, and it was highly advanced. So I actually don't see that. I mean, we can have a longer conversation about the mechanisms, but I don't see that as an obstacle. The bigger obstacle, I think, when it comes to this is you don't want sub-Saharan Africa to be a low road, right? So China is actually an innovator in this space with concrete, but right, in some ways, because building in Africa doesn't necessarily go against its national tally of global emissions, of carbon emissions, it's easy to dump the old mixes, right? So that, I think, is the bigger concern.
When I was in Turkey, I appreciate you bringing up the earthquake and the devastation. I've heard a lot of stories in the recent few days about how cement mixes are being diluted, and that's why they haven't stood up to the earthquake. But one of the things that I heard before the earthquake was how construction workers, skilled construction workers, were very hard to find in Turkey because they were being hired by European countries.
Yeah.
So I second your immigration policy proposal, but I also worry about maybe the skills being depleted in other places when we
yeah, you're absolutely right. That's a really, actually, so one of the things, so I just did some field work with Cemex, which is why I'm thinking about them, but one of the things that they said is that, they're trying to do all these green transitions in their plants in the U.S. They have a couple of plants in the U.S. And they keep cannibalizing their operations in Mexico, bringing in engineers, bringing in frontline staff, because they cannot find the expertise in the US, which is really like a sad story for the US. But I think the question then is, skill is not a stock, it's a process. So then the secondary question would be, how do you create the institutions that foster that process? And in none of the environmental regulation that we have passed do you have a major emphasis on that. All you have it's a very market-based approach. So we'll subsidize the use of low carbon concrete. But like how you get people who know how to use this stuff, like that's nowhere in there. And there's no contemplation of the need to develop the institutions for that.
Out of time. Thank you.
Thank
Natasha.
you.